Another video by Mr. Kabungo. All right, so this video is going to be about, again, polynomial. This time we're going to dive in and talk about extrema. What does that even mean, extrema? What are you talking about, Mr. Kabungo? Well, check this out. So you see those two graphs, and I'm going to focus on the first graph right here, graph numero uno. With graph number one, it says, is the a value of this polynomial positive or negative? I'll let you think for a second. Think. Now remember. All right, so we have a direction facing downward, and then we have one that goes, so we started at the bottom. Now we're here. So started at the bottom, now we're here. So that tells you that that's going to be a positive. So the a value is positive. Now, I don't know if it's exactly 1. For now, we're just going to say positive 1, right? And also, that will have to be an odd exponent, but that will be a question number 2 soon here. So that is a positive exponent. Started at the bottom, now we're here. What? B. Want to check B. B says, is the degree of this function even or odd? It has to be odd. How do we know it's odd? Because there is a bottom, there is a top. That got to be an odd. Or it would have been top, bottom. Just as long as the opposite, right? If they're opposite sign, opposite arrows, then you got to have an odd, right? So B is a check. Let's go to C. C says, can this function be a cubic? Cubic meaning to the third power. Well, we got this. Well, you know what we're going to do? We're going to count this thing. All right, let's count it. So this is a cross. Cross. That's numero uno. Cross. And then it goes, it gets over here. Turn. Tangent. 2. And it gets over here. Cross. 1. Cross 1. Let's add up these numbers. So we have the 1 plus the 2 plus the 1 plus the 1. We get what? 1, 2, 3. We get 5. That is nowhere to be 3. So this is not cubic. Not cubic. This is enough explanation right there. Right? This would be raised to the 5th power. All right, let's move on. D. D says determine the number of relative extrema in this graph. So you probably wonder what in the heck extrema means. It means the following. Extrema refers to all those turning points. Like this one right here would be an extrema. This right here is an extrema. All the vertex, right? All the vertex are the extrema. So we have 1, 2, 3, 4. We have 4 of them, right? So we call them relative extrema, like your cousins, relatives. So cousin 1, cousin 2, cousin 3, cousin 4, and so on, right? Relative extrema. But out of those relative extrema, we have the one that we put a high respect on. We call the absolutes. They're like the kings, right? Kings and the queen, like absolute extrema. What does that mean? That means they are the maximum of the maximum. So somebody would think that this would be, what about this one? That means I'm looking for absolute extrema means the highest extrema or the lowest extrema. So this will not be 1. It will not work. Why? Because this line goes on forever. So I don't have the lowest of the lowest. Out of all the extrema, I don't have the lowest of the lowest. Well, someone else might say, well, Mr. Kabungo, what about this one being the highest, right? This one meant to be the minimum. I'm saying this one being the highest. Well, I would tell you, you're wrong. It would not be the highest because we have an arrow going that direction forever. So what we have to say is we have none. If you have arrows going down and up, none. So we don't have anything right there. All right. So we're done with this. Let's check out the number 2. Number dos. All right. So is the a value of this polynomial positive or negative? Well, look, they're both facing down, down. If they're both facing downward and downward, then the a value would have to be a negative number. If they were both facing upward and up, the a value would have to be positive. Moving on to B. Is the degree of this function even or odd? Well, I'm going to tell you right now, without even doing any work, if they're both facing upward, the same direction, then it's even. Or if they're both are facing downward, it's even. Well, and let's say you just want to do the extra work because you just like to do the extra work. Boom, cross, 1. Boom, cross, 1. Boom, cross, 1. Boom, cross, 1. All right. So add them up. Add them up. So 1 plus 1 plus 1 plus 1. Oh, plus 1. How many of them I have? 1, 2, 3, 4. All right. You get 4. So it is even, but this so it is even, so 4. So the question is, can this be a cubic function? No, we just determined that it's not, because this would be an x to the 4th, right? So it's not a cubic. Determine the number of relative extrema. All right, so relative extrema, that means your cousins. How many do you have? How many vertex do you have, right? Just in general, how many of them do you see? Well, let's count them real fast. So I count 1, 2, 3, 4, 5. I have 5 of them. Now, out of all your 5 cousins that you see over here, we want to know how many absolute extrema, like the highest of them all. In this case, we do have some of them. It's right here. We have the highest absolute. We will call this an absolute maximum. All right, absolute maximum. I can't even spell maximum right now. So we do have one. We have a 1 maximum. But do we have a minimum? No, we do not, because the error goes down forever. So I don't even see a minimum here. This will not work for the minimum because the error goes down. So it has to be the highest point or the lowest.